Okay, here's a pretty good problem for Alex, or from Alex, that I think is good to talk about here. A mixture of gaseous reactants is put into a cylinder where a chemical reaction turns them into gaseous products. The cylinder has a piston that moves in or out as necessary to keep a constant pressure on the mixture of 1 atmosphere. The cylinder is also submerged in a large insulated water bath. From previous experiments, this chemical reaction is known to release 123 kilojoules of energy, and then the temperature in the water bath is monitored, and it's determined that 190 to 90 kilojoules of heat flows into this system right here during the reaction. Now, I already answered these in Alex, but I thought it was good just to explain to you what it is that I did. Okay, so the first question it asks is the reaction exothermic or endothermic? That is, does it absorb heat, in which case it'd be endothermic, or does it give off heat, in which case it's exothermic? Well, in this case, we know that from the description that 190 kilojoules of heat flows into the system. It flows into the system. That is, the water temperature is actually going to go down because that heat is going into the system. It doesn't give off heat, it absorbs heat. So that is, by definition, an endothermic reaction. Does the temperature of the water bath go up or down? We just kind of answered that. It definitely goes down because heat flows into the system from the water bath. So it has to go down in this case. Does the piston move in or out? Well, it depends what's happening here. And so we know that delta E equals heat plus work. Okay, so it tells us what delta E is going to be is 123 kilojoules. 123 kilojoules equals the heat. Okay, that heat flows into the system. When heat goes into the system, that is positive. From lecture, we know that 190 kilojoules plus work. Okay, now the system releases that energy. That has to be a negative. If the system gives off energy, remember, that is negative. So to solve for work, that's going to equal minus 123 minus 190. And so when all is said and done, then the answer is going to be 313. Negative there tells the direction of the work. Okay, so some kilojoules. So the system that is negative, work is negative in this case, and if if work is negative, that means the system is doing work, if you remember from lecture. And so if it's doing work, that piston is going to move out. Okay, so that would be this answer. Does the gas mixture do work? We already said it does work. And how much work is it doing? It's doing 313 kilojoules worth of work. And so that's how I answered that question. A lot of good concepts there that we have to keep in mind. So again, remember, our change in energy equation here consisting of both work and heat. Just keeping those signs is so important to keep those signs in the correct.